Hello, our names are Annabella Gagnon, Emma Crispo, and Zoya Salim. Today we will be doing a presentation on the DepLife radar and its advancements in efficiency and technology. Our presentation will focus on the idea of how DepLife shows how emerging technologies can improve police awareness, as well as the limitation of ways. Our presentation will speak about why DepLife matters, DepLife and how it will expand efficiency, officer safety and efficiency, operational performance and limits, legal privacy and policy implications, and then a summary at the very end. Uncertainty is one of the most dangerous parts of law enforcement, creating the need for better technology for police officers and our first responders. The Department of Homeland Security has supported the development of technologies that will better help erase the uncertainties. DepLife is one of the technologies arising from this project.
All right. What is DepLife? DepLife is a through-wall sensing system developed with support from the Department of Homeland Security Science and Technology Directorate and later transitioned to industry partner with Max-centric technologies. At a basic level, DepLife is designed to detect the presence of living people behind walls, including individuals who are standing, moving, or even lying still. It is intended as a decision support tool, not as a replacement nor human judgment. For this presentation, it is important to note that DHS does not evaluate DepLife only in laboratories. Instead, the DHS emphasizes operational field assessments, where real responders test the technology under realistic conditions. Officer safety and efficiency. Field testing is central to understanding whether emerging technologies actually work in practice. DHS conducted Operational Field Assessment, or OFAs, to evaluate DepLife. These assessments were carried out with law enforcement and fire personnel, not just engineers or researchers. During testing, DepLife was evaluated in scenarios that reflect real-world conditions, including empty rooms, rooms with stationary individuals, and rooms with moving individuals. These tests revealed that while DepLife often successfully detected the presence of life, performance varied depending on conditions such as wall type, movement, and placement of the device. This is important because it highlights a key lesson. Technology that performs well in theory does not always perform consistently in practice. Responders identified several potential applications, including improving situational awareness before entering a room, supporting tactical decision making, and assisting in search and rescue or disaster response scenarios. Um, Now moving forward to our first graph and visual. Um, this graph represents the surveys and the answers given from 9 officers completing multiple surveys in different environments testing the DepLife technology. The answers range from strongly disagree to strongly agree, with the outliers being not applicable. As we can see that the graph is skewed heavily to the left, and this means that many of our responses, even in alternate environments, showed that the DepLife technology was effective in communicating the number of people, location, position, and movement of any entities beyond a surface or wall that is not visible to these officers.
Positive feedback was also given relatively to the software reliability and usability. The graph shows here officers' opinions on how intuitive and easy was to interpret the data showed on the display, with an overall satisfied thought on the radar's overt and covert alerting modes. No one disagreed on being capable of operating the hardware and setting up the software. And even if there was a noticeable amount of non-responders, the general agreement of 243 officers is a great sign for future development. But what is development without a few itches? As expected, there were limitations of DepLife efficacy, highlighted by trials, of which the common ones related to false positives. The radar had indeed difficulty detecting life in the exterior scenarios, with the general result of at least 2 people encountering a false positive in each scenario. The main reason attributed to the better application on interior walls might be because of a stable placement still needed by the hardware to send off and get back the signal. Even though there's plenty of time to implement a more stable, sufficient design, it's good to notice how these errors could amplify detection risks, potentially implying a higher stake in terms of time and resources. These questionnaires make clear that DepLife is not a silver bullet yet, so its use should support, not replace, human judgment and training. Which brings us to another important issue beyond technical performance, that is the technology's ethical and legal implications. False positives can indeed lead to tactical delays, misinterpretations of data visuals that could mean wasteful and expensive resources used, and the public mistrustful attitude. Through-wall sensing technologies introduce privacy concerns too, especially if used outside narrowly defined law enforcement or emergency contexts, like, for example, police warrants. There's also a risk of over-reliance on algorithmic tools where users may trust technology more than their own training or situational awareness. As a result, the DHS emphasizes the importance of solid standard operating procedures, which ensure proper training on how and when to operate the radar.
As stated, DepLife is an emerging technology designed to reduce uncertainty for first responders. DHS field testing shows both the pros and cons of DepLife, as well as the responsible deployment and understanding. DepLife helps increase situational awareness while reducing uncertainty and police exposure. At the same time, though, it is not a total risk elimination, and it does have some oversights and technical malfunctions that do need to be worked out. DepLife helps demonstrate the overall idea of technological advancements happening in law enforcement and how there will always be pros and cons despite the help that it can make.
Here is our sources. We got information from the U.S. Department of Homeland Security, Science and Technology Directorate, the Lincoln Library from MIT, Federal Emergency Management Agency, and U.S. Fire Administration, and all listed afterward. Thank you.